All right, today we're getting our hands on a tool that honestly has less to do with a stuffy math class and way more to do with your real life. We're talking about probability. We're going to break down how it's really the hidden science behind making smarter choices every single day.
So let's just start with a really simple but, a pretty powerful question. What if you could just get better at making decisions? I'm not even talking about the huge life-changing ones. I mean the small, everyday choices, the ones that really add up. That, right there, is the real promise of getting a handle on probability.
And the reason we need a tool like this is because, let's face it, every decision we make is clouded by uncertainty. But uncertainty isn't just one big blob. It's really a mix of two things. What we call epistemic limits, that's the stuff we just don't know yet, and aleatory limits, which is just pure, unadulterated randomness. Probability is how we build a bridge across that gap.
So let's be super clear about one thing. Probability is not some crystal ball. It doesn't predict the future. Think of it more like a language, a structured way of thinking that helps us measure and navigate a world that is and always will be uncertain.
Now, to really get this, you have to understand that there isn't just one way to think about probability. There are actually two major schools of thought, two different flavors, if you will, for how we even define chance in the first place.
And here's the fundamental split. You can pretty much boil it down to data versus logic. On one side, you've got the frequentist view. They'd say, probability is just what happens over the long run. It's all objective, based purely on data from doing something over and over again. But on the other side, you've got the a priori view. That literally means from the former. And this way of thinking says probability is all about logic. It's what you figure out before you even collect any data.
Let's dig into that frequentist idea a little more. Say you want to know the probability of a coin landing on heads. A frequentist would just say, well, let's flip it a few thousand times and see what we get. The probability is just the number that shakes out over all those trials. It's all about what you can observe and repeat. No feelings, just data. Okay, now contrast that with the a priori approach. Before you even touch a standard fair die, you can figure out that the chance of rolling, say, a 4 is 1 in 6. Right? You don't need to roll it 1,000 times to find that out. You just know it has 6 equal sides, so you use logic to get to the probability. It's a belief you build from the structure of the problem itself.
All right, so we've got these two ways of looking at probability. But things start to get really fun and, frankly, a lot more like the real world when we look at how different events crash into each other, which brings us to our next section, when events collide.
So, first up, we have independent events. This is the simplest case. Think about flipping a coin and then rolling a die. These two things are totally independent. The result of that coin flip has absolutely zero, zilch, nada effect on what number comes up on the die. They're just in their own separate little worlds.
But most of the really interesting stuff in life involves dependent events. A classic example is drawing cards from a deck without putting them back. I mean, if you pull an ace on your first draw, what just happened to the odds of the next card being an ace? They just went down, right? The first event totally changed the probabilities for the second one.
So how do we actually deal with that? How do we calculate things when events are all tangled up like that? Well, the tool for the job is called conditional probability. It's the math that lets us answer questions like, what's the chance of B happening given that A already happened? This is the engine that drives our understanding of a world where everything is connected.
Okay, so we've looked at the philosophies, we've covered the rules for how events interact, now it's time for the payoff. How do we take all these ideas and use them for our real goal here, turning chance into actual better choices?
And the main engine for this is an incredibly powerful idea called Bayes' theorem. And this quote really says it all. It operationalizes rational belief revision. I know, that sounds complicated, but all it really means is that it's a formal recipe for learning from experience, for updating what you believe in a way that actually makes sense.
And the process itself is super intuitive. It's basically what our brains try to do naturally, just with a bit more rigor. You start with an initial belief, your a priori probability. Then, step 2, you go out and gather some new evidence. And finally, step 3, you combine those two things to get your new, updated belief, your posterior probability. See? It's just a cycle of learning, written down.
Now, that middle step, likelihood, that's the real magic. That's the engine. It's the part that asks the crucial question. Okay, how strong is this new evidence I just saw? It basically measures the weight of your data, telling you exactly how much you should let it change your original belief.
And the result you get at the end of all this is your posterior probability. And this isn't just another guess. It is your new, refined, evidence-based belief. It's what you used to think, intelligently updated by what you just learned. This is the formal output of learning.
So now we know how to update our beliefs. That's awesome. But what about when you have to actually choose between different actions? For that, we turn to another super practical tool, expected value. What this does is let you calculate the long-run average outcome of a decision, giving you a hard number you can use to compare your options.
Let's make this real. Imagine a business venture. There's a 20% chance it succeeds and you make $10,000, but there's an 80% chance it fails and you lose $1,000. To get the expected value, you just multiply each outcome by its probability and add them together. And what do you get? A positive $1,200. This tells you that even though you're likely to fail on any single try, on average, this is a smart bet.
Now, using all these cool tools means we also have to be aware of the mental traps we can fall into. And the most famous one of all is the gambler's fallacy. This is that gut feeling you get at the roulette table after you've seen 5 reds in a row, that feeling that black is somehow due. It's not. Remember independent events? The roulette wheel has no memory. The coin has no memory. Past random events have no influence on the future.
So, what's the big takeaway here? Probability is not about predicting the future. It's not magic. Its real, true power is that it helps you weigh all the possibilities and make the absolute best choice you can with the information you have, right here, right now.
And really, that's what it all comes down to. The world out there is always going to be a random, uncertain place. But with these ideas, your choices, well, they don't have to be. So the only real question left is, what will you decide next?